Have you ever paused, just for a moment, and wondered whether the things you call vast are actually, well, rather small when set against the true scale of the universe? You know, whether the galaxy you imagine as a sprawling island of stars might in fact be little more than a delicate grain of dust floating in something far, far bigger than we ever allow ourselves to picture. Because when you look up at the night sky, perhaps from a quiet street or a dark hillside, it feels enormous, doesn't it? Almost overwhelming, and yet that feeling itself might be misleading. Our minds, shaped by fields and oceans and city skylines, were never designed to grasp distances measured not in miles or hours, but in light itself. And that's the thing, you see, the universe plays tricks on our intuition. A galaxy appears immense because it glows, because it has structure and beauty and billions of stars bound together by gravity like a cosmic city. But if you gently pull the camera back, if you let your imagination drift outward, you begin to notice something unsettling and strangely beautiful. Those galaxies, even the grandest ones, begin to shrink. They recede into points. They become whispers against an ocean of darkness and space. And perhaps that raises a deeper question, one that lingers quietly in the background. If galaxies themselves are small, astonishingly small, then what does that say about our place within them? About the stories we tell ourselves as inhabitants of a single star on the edge of one such island? There's a kind of humility hidden in that thought, but also wonder, because to be small in a universe this vast is not to be insignificant. It is simply to be precisely where we are meant to be, observers made of stardust, trying to understand the true proportions of the cosmos. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world, and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. When we talk about size, when we casually describe something as big or small, we almost never pause to consider what those words are actually anchored to. Big compared to what, exactly? Small relative to which frame of reference? Because size in the universe is never absolute. It only exists through comparison, and the moment you change the comparison, the meaning dissolves and reforms into something else entirely. And perhaps that is where the quiet unease begins. Because the universe does not share our sense of proportion. It does not respect the scales our minds find comfortable. It stretches itself far beyond them, patiently, indifferently, waiting for us to catch up. You see, our intuition was forged on a very narrow stage. We evolved to judge the distance between a tree and a river, between a predator and a hiding place, between home and the horizon. We are exquisitely good at that. Our brains are masterpieces of local geometry. But the cosmos, the cosmos operates on scales that were never relevant to survival. No ancestor of ours ever needed to comprehend the distance to the nearest star in order to find food or shelter. And so, when we try to picture the universe, our intuition falters. It guesses, it compresses, it simplifies, and in doing so, it quietly betrays us. Let us start close to home, because that is always where understanding begins. The distance between the Earth and the Sun feels, in everyday language, enormous. We speak of it with reverence. We imagine heat traveling across that gulf, light pouring outwards, sustaining life. Scientists give this distance a name: the astronomical unit. It is a convenient measure, a way of saying this is the typical spacing between a planet and its star. Light takes about 8 minutes to cross that space. 8 minutes, long enough to make a cup of tea, long enough to pause to breathe. And at first, that feels manageable, almost intimate. But then, perhaps, we try an experiment of the imagination. We shrink the sun down to the size of a grapefruit and place it in the center of a large open field. Where does the Earth go? It becomes a grain of sand, orbiting tens of meters away. And suddenly something unsettling happens. The solar system, which felt rich and full and busy in our minds, becomes mostly nothing at all, empty space. Vast, silent, unoccupied. The planets are tiny flecks suspended in a volume that is overwhelmingly void. Already at this modest scale, the universe is teaching us its first lesson. Space is not filled, it is emptied. Now push just a little farther outward, and that sense of emptiness becomes almost unbearable. Beyond the orbit of the outer planets lies the interstellar gulf. The nearest star beyond our sun is not slightly farther away. It is staggeringly farther away. Astronomical units collapse under the weight of that distance. They become useless, and so we invent a new measure, the light year. Not a measure of time, despite the name, but of distance. The distance light travels in 1 year, racing through the vacuum at a speed woven into the very structure of space-time. And that distance is vast beyond ordinary comprehension. The nearest star is a little over 4 light years away. 4 years. 4 entire revolutions of the Earth around the sun for a beam of light to make the journey. And between here and there is nothing. No gentle haze. No invisible medium carrying waves. Just darkness and separation. And this is where the human mind begins to resist, because 4 light years sounds like a number we can say, but not one we can feel. We do not experience years as distances. We experience them as memories, as aging, as change. And so when distance is expressed this way, our intuition simply shrugs and moves on. Well, you see, this is not a flaw in our intelligence. It is a reflection of our history. Our brains are pattern recognition machines tuned for a very specific environment. They are brilliant at storytelling, at stitching together cause and effect across human scales. But they are poor at exponential growth, poor at appreciating emptiness, poor at holding truly enormous ratios in a way that feels meaningful. And the universe is built almost entirely from those things. As we zoom outward again, astronomers introduce yet more units. Distances measured not in light years, but in thousands of them. Kiloparsecs, and then millions. Megaparsecs. At this point, the language itself begins to feel abstract, almost ceremonial. These are not numbers meant to be visualized. They are numbers meant to be handled carefully, like fragile glassware, by mathematics and observation. A kiloparsec is roughly the distance across a substantial chunk of a galaxy. A megaparsec spans the gulf between galaxies. And by the time we are speaking this fluently, we have left the realm of pictures behind entirely. And yet we keep trying to draw pictures anyway. We see illustrations of galaxies crowded with stars, swirling majestically, filling space with light. And they are beautiful, they are inspiring. But they are also deeply misleading, because they compress distances by factors of millions or billions. They show stars as neighbors when in reality they are separated by gulfs so large that even light takes years to cross them. A truly accurate depiction of a galaxy would be almost invisible. A few faint points scattered across a vast black canvas. No spiral arms, no glowing disks, just emptiness punctuated by isolation. This is why the human brain struggles so profoundly with cosmic scale. When confronted with emptiness, it becomes uncomfortable. It fills in the gaps, it invents structure. It prefers density because density feels meaningful. Emptiness feels like absence, like a failure of imagination. But in the universe, emptiness is the rule, not the exception. Matter is the anomaly. Structure is rare. And the more closely we examine the cosmos, the more this truth asserts itself. Consider the solar system again, because it offers a perfect microcosm of the larger universe. From the inside, it feels busy. Planets orbit, moons dance. Comets sweep in from the darkness and vanish again. There is motion and rhythm and a sense of cohesion. But from the outside, from even a modest distance away, it dissolves into almost nothing. The sun becomes a faint star. The planets vanish entirely. The entire system occupies a volume of space that is negligible compared to the distances between stars. It is a tiny bubble of complexity floating in a sea of emptiness. And now, with that in mind, think about a galaxy. Galaxies are often introduced as the largest structures we can meaningfully talk about. Cities of stars, islands of light, hundreds of billions of suns bound together by gravity. And yes, that is true. Compared to a planet, compared to a solar system, a galaxy is immense. It is almost beyond comprehension. But here is the subtle and humbling twist. A galaxy is only large when viewed from very close up. Step back far enough and the illusion collapses. A galaxy is thin. It is sparse. It is overwhelmingly empty. Most of its volume contains nothing at all. The stars are separated by distances so vast that even within these colossal systems, encounters are extraordinarily rare. The image of a galaxy as a crowded place is a projection of our own discomfort with emptiness. In reality, a galaxy is more like a delicate fog of matter, structured but tenuous, fragile against the backdrop of the universe. And when you place that galaxy into the larger cosmic context, something almost poetic happens. It shrinks. It becomes a dot, A whisper, a structured grain of dust suspended in an ocean of darkness. The universe does not notice it in the way we do. It is just one configuration among countless others. And that realization can feel unsettling at first, because we have been taught to think of galaxies as grand and dominant, to imagine them as the primary actors on the cosmic stage. But perhaps that discomfort is exactly the point. Perhaps the universe is inviting us to let go of our need for centrality, to accept that significance does not come from size, that complexity and meaning can arise in the smallest of places. After all, our entire experience of existence unfolds on a tiny planet orbiting an unremarkable star on the outskirts of an average galaxy, and yet here we are contemplating the whole. The tools we use to measure the universe are, in a sense, acts of humility. Astronomical units, light years, kiloparsecs, megaparsecs. Each one is an admission that our everyday language is insufficient, that we must stretch our concepts, invent new frameworks, just to keep pace with reality. And even then, we fall short, because no unit can make us feel what it is like to be separated from the nearest galaxy by millions of light years. No number can truly convey the silence of intergalactic space. And still, we persist. We build telescopes. We map distributions of light. We trace the faint gravitational signatures of matter we cannot see. We do this not because the universe demands it, but because something within us does. A quiet, persistent curiosity, a desire to know where we are, even if the answer is unsettling. As we begin to grasp just how misleading our intuition can be, a new clarity emerges. We start to see galaxies not as monolithic giants, but as varied, nuanced structures with very specific dimensions. Some are sprawling spirals. Others are faint, compact collections of stars barely holding together. Their sizes are not uniform. Their shapes are not fixed. And once you have loosened your grip on the idea that a galaxy is inherently huge, it becomes natural to ask a more precise question. Not how big galaxies feel, but how big they actually are. What is their typical diameter? How thick are they really? How much of what we see is light, and how much is empty space between stars? And perhaps most intriguingly, how do these typical galaxies compare to the smallest and faintest ones? The ones that barely register in our surveys at all? Because once you accept that even galaxies are small on the cosmic scale, you are ready to look closer, to examine their true dimensions with a more honest eye. And that is where the story gently drifts next, toward the surprisingly modest sizes of these vast stellar systems, and the quiet realization that even among galaxies, size is a deeply relative and humbling thing. And once that idea settles in, once you allow yourself to accept that galaxies themselves are not the immovable giants we once imagined, but rather delicate structures suspended in immensity, the natural next step is to ask a quieter, more precise question. If galaxies are small in the cosmic sense, then how big are they really? Not how they feel when we see them glowing on our screens or painted across the night sky, but how wide they truly are, how thick, how much space they actually occupy, when stripped of illusion and placed honestly against the dark. And this is where things become gently surprising, because when astronomers began to measure galaxies carefully, not just admire them, a pattern emerged. Galaxies come in families. They are not all the same, but they are not endlessly varied either. There is a kind of rhythm to their sizes, a range that repeats itself across the universe like a familiar chord played in different keys. Spiral galaxies, with their graceful arms and rotating disks, tend to fall within a certain span. Elliptical galaxies, smoother and more diffuse, gather their stars differently but still obey similar constraints. It is as though gravity, given enough time, prefers certain solutions. Take a typical spiral galaxy. From edge to edge, it might stretch across tens of thousands of light years. Some are smaller, some larger, but most live within this narrow band. And among them is our own home, the Milky Way. We often speak of it with awe, and rightly so. It contains hundreds of billions of stars, vast clouds of gas and dust, and a central region dense with mystery. And yet, when we measure it carefully, its diameter is about 100,000 light years. A number that sounds immense, and in human terms it certainly is. But numbers like this are deceptive. They invite reverence while quietly hiding perspective. You see, 100,000 light years is a long way only if you forget what comes next. Because that measurement tells you how far it is from one edge of the galactic disk to the other. but it does not tell you how thin that disk is. And this is where intuition begins to wobble again. The Milky Way, for all its grandeur, is astonishingly flat. Its disk is only a few thousand light-years thick. Compared to its width, it is like a sheet of paper spread across a football field. Almost all of its stars, including our sun, are confined to this thin plane. Above and below it lies emptiness, punctuated only by a sparse halo of stars and dark matter. Pause for a moment and really let that sink in. A structure 100,000 light-years across, yet only a few thousand light-years thick. A vast, spinning pancake of stars drifting through space. From within it, from our tiny position embedded in one of its spiral arms, it feels boundless. But from the outside, it is delicate, fragile, almost ephemeral against the cosmic dark. And the Milky Way is not exceptional. That is perhaps the most humbling part. It is not unusually large for a spiral galaxy. It is not particularly small either. It is comfortably average, one among billions, each tracing out similar dimensions, each shaped by the same physical laws playing out over billions of years. Gravity pulls matter inward. Angular momentum spreads it outward. Gas cools and collapses into stars. Over time, a disk forms, and again across the universe, that disk settles into roughly the same proportions. Elliptical galaxies tell a slightly different story, but not a radically different one. They lack the thin disks and spiral arms. Their stars move in more chaotic orbits, forming smooth, rounded shapes. Some ellipticals are compact and dense, only a few thousand light-years across. Others sprawl wider, reaching sizes comparable to large spirals. But even the biggest ellipticals, the ones that dominate the centers of galaxy clusters, are still modest when placed against the universe as a whole. Their light extends outward gradually, fading into darkness rather than ending abruptly, and beyond that fading glow, there is once again mostly nothing. What is striking, perhaps even unsettling, is how little of a galaxy is actually filled with stars. If you were to travel across the Milky Way, hopping from star to star, you would find yourself crossing vast distances of emptiness between each point of light. The average separation between stars in our region of the galaxy is several light-years. Several years for light to cross. And that is in a relatively crowded neighborhood. Move toward the outskirts, and the spacing grows even larger. The galaxy becomes thinner, quieter, more diffuse. And then there are the galaxies that rarely make it into popular imagination at all. The small ones, the faint ones, the dwarfs. These galaxies are not hundreds of thousands of light-years across. They are not even tens of thousands. Some are only a few thousand light-years in diameter. Others shrink to mere hundreds. Compared to the Milky Way, they are tiny. Compared to the universe, they are almost nothing. And yet they are galaxies all the same. Bound systems of stars held together by gravity, places where matter has managed, against the odds, to organize itself into something coherent. Many of these dwarf galaxies orbit larger ones, like moths around a lantern. Our own Milky Way is surrounded by dozens of them, faint companions that are difficult to see and easy to overlook. They contain far fewer stars, shine far less brightly, and often go unnoticed unless we search for them deliberately. If you were to place one of these dwarf galaxies next to the Milky Way on a true-scale map, it would look like a smudge beside a disk. And if you zoomed out just a little further, both would begin to shrink together. This is the key. Differences that feel enormous at one scale become trivial at another. The contrast between a giant spiral and a tiny dwarf seems dramatic when viewed up close. But step back far enough, and both dissolve into points. This is why typical galaxy sizes matter. They anchor our understanding. They tell us what is normal, what is common, what gravity tends to produce when given enough time and material. And they reveal something quietly profound. The universe does not favor enormity for its own sake. It does not endlessly build larger and larger structures. Instead, it settles into patterns that repeat. Galaxies grow until they reach a balance point, where the available matter, the surrounding environment, and the pull of gravity all find a temporary equilibrium. Beyond that, growth slows. Collisions may occur, mergers may happen, but even then there are limits. Disks thicken, shapes distort. But galaxies do not inflate without bound. They remain in cosmic terms compact. And once again, our intuition rebels. Because we are accustomed to thinking of galaxies as the biggest things that matter. We draw maps where they dominate. We speak of the universe as a collection of galaxies, as though the space between them were merely a backdrop. But the truth is almost the reverse. The space between galaxies is the main feature. The galaxies are embellishments, accents, flecks of complexity scattered through a vast, mostly empty expanse. If you were to compress the universe down to a scale you could walk across, this becomes painfully obvious. Imagine shrinking everything so that the distance across the Milky Way becomes the width of a human hair. On that scale, the nearest large galaxy would be kilometers away, and the vast majority of the space between would contain nothing at all. No stars, no planets, no glowing clouds, just darkness. And yet, we persist in picturing galaxies as crowded, luminous things because light tricks us. Our eyes are drawn to brightness. Structure catches our attention. We ignore the darkness because it offers no visual reward. But the darkness is where the scale truly resides. The darkness is the measure. As we refine our understanding of typical galaxy sizes, another subtle realization emerges. The thickness of a galaxy matters just as much as its width. The fact that galaxies are thin tells us something fundamental about their history. It tells us that they formed from rotating clouds of gas, that over time, random motions were damped out, leaving stars moving in orderly orbits. It tells us that gravity, left undisturbed, tends to flatten systems. This is not just a detail, it is a clue, a fingerprint of the processes that shape the cosmos. And then there is the halo. Surrounding the thin disk of a galaxy is a much larger, much more mysterious structure. A spherical halo of dark matter, invisible and vast, extending far beyond the visible stars. This halo does not shine, it does not form stars, but it dominates the galaxy's mass, and its size dwarfs the luminous part. The Milky Way's dark matter halo may extend several times farther than the visible disk. Suddenly, the 100,000 light-year diameter feels less definitive. The galaxy's influence stretches much farther, quietly shaping the motion of stars and satellites far beyond the glowing edge. Even so, even when we include this invisible component, the galaxy remains small on the grandest scales. Its gravitational reach fades into the background of the universe. It becomes one node among many, one island in a cosmic sea. And this is where the story naturally leans forward again. Because if typical galaxies are this modest in size, if even the Milky Way is a thin, delicate structure compared to the void around it, then what about the galaxies that fall below this norm? The ones that never grew large. The ones that hover at the threshold of visibility. The dwarf galaxies that make up the majority of galactic populations in the universe. Once you begin to notice them, once you adjust your expectations and your sense of scale, they appear everywhere. Small, faint, easy to miss, and yet, collectively, they may tell us more about the universe than the giants ever could. They are the quiet majority. The background hum beneath the cosmic symphony, and understanding their sizes, their fragility, and their abundance pulls us gently, almost inevitably, into the next layer of the story. Toward those forgotten points of light that challenge our assumptions about what a galaxy is, and remind us once again that in a universe this vast, even greatness comes in unexpectedly small packages. And once your sense of scale has softened enough to accept that even a galaxy like the Milky Way is a thin, restrained structure rather than an all-consuming giant, your attention naturally drifts toward the quieter shapes lingering at the edge of perception, because there is a subtle imbalance in the story we usually tell. We talk about spirals and ellipticals, about majestic disks and luminous cores, as if these were the dominant forms of matter in the universe. But they are not. They are simply the loudest, the brightest, the easiest to notice. And in a universe where light so easily misleads us, that bias matters. Most galaxies are not grand. Most do not blaze across space with sweeping arms or dense central bulges. Most are small, faint, and almost apologetic in their presence. These are the dwarf galaxies, and they vastly outnumber their larger cousins. Once you begin to look for them, once you tune your instruments and your expectations to their scale, they appear everywhere, clustering around larger galaxies, scattered through groups, lingering in the shadows of cosmic structure, like quiet thoughts we rarely pause to acknowledge. A dwarf galaxy is not defined by a single strict boundary, but by a sense of modesty. Its diameter may span only a few thousand light years. Some are even smaller, mere hundreds of light years across. Where a galaxy like the Milky Way holds hundreds of billions of stars, a dwarf might contain only a few million, sometimes far fewer. And yet, gravity binds them just the same. Stars orbit. Dark matter weaves its invisible scaffold. History unfolds. These are not failed galaxies. They are complete ones, simply operating on a gentler scale. What makes dwarf galaxies particularly easy to overlook is not just their size, but their light. They shine faintly. Their stars are spread thinly across space, their glow diluted by distance and darkness. Against the black canvas of the universe, they barely register. Even relatively nearby dwarfs can remain hidden for decades, revealed only when surveys become sensitive enough to notice subtle overdensities of stars moving together through space. In some cases, we discover them not by their light at all, but by the way they disturb their surroundings, by the gentle gravitational tug they exert on streams of stars. Our own Milky Way is encircled by dozens of these diminutive companions. They drift around it like moths around a lantern, bound but distinct. Some follow elongated orbits, diving close before retreating again into the dark. Others linger farther out, barely tethered, as though contemplating escape. Each one is a record of cosmic history, a survivor of formation processes that played out billions of years ago. And yet, because they are small and dim, they rarely appear in our mental image of the galaxy. We imagine the Milky Way as an isolated disk, forgetting the quiet swarm that accompanies it. If you could see the universe the way gravity does, without favoring light, dwarf galaxies would loom far larger in importance. They are the most common outcome of galaxy formation. When matter collapses under gravity, it does not always gather enough mass to form a grand spiral or a massive elliptical. Often, it stalls early, forming a small, fragile system. And that is enough. The universe does not insist on extravagance. It allows simplicity. There is something deeply humbling about this. The structures we celebrate, the galaxies that grace textbooks and wallpapers, are statistical outliers. They are the exceptions, not the rule. The rule is smallness. The rule is faintness. The rule is that most matter organizes itself into modest clumps, drifting quietly through space, barely announcing their existence. And this realization subtly reshapes how we think about scale. Because if dwarf galaxies dominate numerically, then any honest map of the universe must be dotted primarily with points that are almost invisible. The bright spirals and ellipticals become landmarks, yes, but the background is filled with whispers. And when you zoom out far enough, when you compress cosmic distances onto a single page or screen, those whispers vanish entirely. They do not even make it to a pixel. They are erased by scale. This is why dwarf galaxies feel forgotten. Not because they are rare or unimportant, but because our tools and our senses are biased against them. We see what shines. We miss what does not. And yet, these small galaxies may hold some of the most important clues about how the universe came to be the way it is. They are chemically simple, often composed of ancient stars that formed early in cosmic history. They have not undergone the same cycles of mergers and starbursts that larger galaxies have. In that sense, they are fossils, preserving conditions closer to the early universe. Their small sizes make them fragile. Interactions with larger galaxies can strip them of gas, distort their shapes, even tear them apart entirely. Some dwarfs near the Milky Way are little more than elongated streams of stars, slowly dissolving under tidal forces. Their very existence is temporary on cosmic timescales. And yet, there is a quiet dignity in that fragility. They remind us that the universe is not static. That structure is constantly forming and unforming, assembling and dispersing. Imagine zooming out from one of these dwarf galaxies. At first, it appears as a faint smudge, a loose gathering of stars. Zoom out a little more, and it becomes a dot. Zoom out further still, and it disappears. Not because it is gone, but because your map can no longer afford the resolution to acknowledge it. This is what happens when scale overwhelms detail. The universe does not become simpler. It merely becomes less legible to us. And this brings us back to the illusion that galaxies are large. When we see images of the cosmos, galaxies dominate the frame because the frame has been chosen to suit them. But if we were to draw a truly honest map of the universe, one that spans hundreds of millions of light years, galaxies would shrink to pinpricks. Dwarf galaxies would not appear at all. They would be smaller than the ink used to draw them. This is not a failure of representation. It is a reflection of reality. The universe is mostly empty. Matter occupies a vanishingly small fraction of its volume, and within that matter most structures are modest. Complexity arises not from abundance, but from organization. There is something almost philosophical in this. We tend to associate importance with size, with brightness, with dominance. But the universe seems indifferent to those values. It allows vast numbers of small things to exist quietly, shaping the cosmos collectively even if no single one stands out. Dwarf galaxies may be individually insignificant on a cosmic map, but together they outweigh the giants in number. They form the scaffolding upon which larger structures assemble. In many theories of cosmic formation, large galaxies grow by consuming smaller ones. Dwarf galaxies fall in, merge, dissolve, and contribute their stars and dark matter to larger systems. In this sense, the Milky Way itself is a composite, built from countless small pieces accreted over time. The stars around us may once have belonged to galaxies that no longer exist, their identities erased by gravity. The quiet majority feeds the visible few. And so, when we speak of dwarf galaxies as forgotten, what we really mean is that our perspective has been incomplete. We have focused on what is easiest to see, not on what is most common. And once you adjust your view, once you accept that most galaxies are small and faint, the universe begins to look very different. Less like a collection of grand objects floating in space, and more like a delicate network of tiny nodes embedded in an ocean of darkness. This shift in perspective prepares us for something even more unsettling. Because if most galaxies are small, and if even the largest are modest compared to cosmic distances, then what happens when we encounter the rare exceptions? The galaxies that did manage to grow enormous, the ones that defy the typical scale and stretch across hundreds of thousands or even millions of light years. They exist, they are real, but they are anomalies, and understanding just how unusual they are requires us to hold firmly to everything we have learned so far about scale, emptiness, and proportion. Only then can we appreciate how strange those giants truly are, not as confirmations of grandeur, but as exaggerated outliers in a universe that overwhelmingly prefers restraint. And as your imagination steadies itself, as it learns to navigate a cosmos where smallness is the norm and vastness is relative, the path forward becomes clear. The story naturally turns toward those rare, colossal galaxies, not to celebrate their size, but to place it carefully, honestly, against the vast, indifferent backdrop that makes even giants feel small. And with that understanding, with the quiet acceptance that most galaxies live modest lives in the shadows of our attention, it becomes possible to notice something else entirely. Because nature, you see, is never content with uniformity alone. Wherever there is a rule, there are exceptions. Wherever there is a typical scale, there are outliers that stretch it, test it, exaggerate it to the edge of plausibility, and galaxies are no different. Hidden among the countless small and average systems are a handful of giants, structures so vast that even astronomers pause when they first grasp their dimensions. These are the largest galaxies ever observed, and they exist not to contradict what we have learned, but to sharpen it. At first glance, the idea of a truly enormous galaxy feels reassuring, almost comforting. We are drawn to extremes. We like the thought that somewhere out there exists something undeniably grand, something that lives up to our instinctive sense of cosmic scale. And indeed, there are galaxies whose diameters stretch not merely across hundreds of thousands of light years, but across millions. Compared to the Milky Way, these systems seem almost absurdly large. Their halos of stars extend far beyond what we once thought possible. Their faint outer regions blur into the darkness, not because they end abruptly, but because their light grows too thin to stand out against the cosmic night. These supergiant galaxies are often found at the centers of galaxy clusters, places where gravity has had an exceptionally long and violent history. Over billions of years, smaller galaxies fall inward, merging, dissolving, surrendering their stars to a growing central mass. Each collision adds to the outskirts, puffing the galaxy outward, extending its reach. What emerges is not a neat spiral or a tidy ellipse, but something more diffuse, more ghostly. A colossal envelope of stars, spread so thinly that from within, you might not even realize you were inside a single structure. And yet, even here, even in the presence of such extravagance, scale continues to play its quiet trick. Because while these galaxies are immense compared to typical ones, they are still astonishingly small when placed in their true cosmic context. A galaxy that spans 1 million light-years feels unimaginable, until you remember that the distance between clusters of galaxies can be tens or hundreds of millions of light-years. Against that backdrop, even the largest galaxies shrink back into modesty. There is something almost ironic about this. The galaxies that appear most extreme are, in a sense, the most vulnerable to misinterpretation. Their size tempts us to elevate them, to see them as dominant features of the universe. But step back far enough and they lose that privilege. They become points again. Slightly larger points, perhaps, but points nonetheless. In a truly zoomed-out view of the universe, the difference between a galaxy 100,000 light-years across and one 1 million light-years across becomes negligible. Both are swallowed by scale. This is why these giant galaxies are best understood not as confirmations of cosmic grandeur, but as exaggerated exceptions. They are statistical outliers produced by very specific circumstances, dense environments, long histories of mergers, favorable gravitational wells. Remove any one of those conditions, and the giant never forms. The universe does not churn out behemoths casually. It requires patience. It requires time. It requires a precise choreography of motion and mass. And even when all of that comes together, the result is not a dense, bustling metropolis of stars. Quite the opposite. These galaxies are often diffused to the point of near invisibility at their edges. Their stars are so spread out that the night sky within them would feel eerily empty. You could travel for immense distances and see very little change. The galaxy would not announce itself loudly. It would whisper. This challenges another deeply held intuition. We tend to associate size with substance. We imagine that something larger must be denser, richer, more crowded. But the largest galaxies defy that expectation. They are large precisely because they are diffuse. Their mass is smeared across space, their brightness diluted, their identity blurred. In some sense, they are less galaxy-like than their smaller cousins, less defined, less structured, more like extended clouds of stars than coherent systems. And this brings us to an important realization. Size alone does not confer significance. A galaxy that spans 1 million light-years is not necessarily more interesting or more complex than one 1,000 light-years across. Complexity lives in structure, in interaction, in history. Some of the smallest dwarf galaxies preserve ancient stars formed when the universe was young, untouched by later chaos. Some medium-sized spirals host intricate patterns of star formation, magnetic fields, and dynamic processes. The giants, for all their scale, may be relatively quiet places. There is a kind of poetic symmetry here. The universe allows both extremes. Tiny, faint galaxies barely holding together, and enormous, diffuse ones stretching across vast distances. But neither extreme dominates the story. Both are rare. The typical galaxy remains modest, and that tells us something profound about how the cosmos prefers to organize itself. When we place these giant galaxies into the larger framework of the cosmic web, their humility becomes even clearer. The cosmic web is composed of vast filaments of matter stretching across hundreds of millions of light-years, intersecting at nodes where galaxy clusters form. Along these filaments, galaxies gather like dew on invisible threads. Compared to the length of a filament, even the largest galaxy is a minor embellishment, a small knot in a much larger pattern. And within galaxy clusters themselves, scale continues to conspire against intuition. A cluster may span tens of millions of light-years. It may contain hundreds or thousands of galaxies. And yet, even there, galaxies rarely touch. The space between them remains enormous. Collisions are rare, and when they do occur, they unfold over hundreds of millions of years. What looks dense from afar is still overwhelmingly empty. So when we speak of the largest galaxies ever observed, it is worth remembering how carefully that phrase must be held. Largest relative to other galaxies, yes, but not large relative to the universe. Not even close. They are like oversized grains of sand on an endless beach, noticeable only because we are standing nearby, kneeling down, examining the texture. And perhaps that is the deeper lesson these giants offer. They remind us that scale is slippery, that our sense of wonder must be recalibrated constantly. The universe is not impressed by size. It is governed by relationships, by the balance between gravity and expansion, by the quiet tension between matter and space. As we allow this perspective to settle, Another question begins to surface, almost uninvited. If even the largest galaxies are so small compared to the spaces between them, then what does that say about those spaces themselves? About the vast gulfs separating galaxy from galaxy? About the emptiness that dominates the universe by volume? Because we have spent so long talking about the things that shine, the things that clump together, that we have barely acknowledged the true main character of the cosmos. The space between galaxies is not a minor detail. It is the dominant feature. It defines the scale. It sets the stage upon which all structure appears. And once you start to appreciate how even the greatest galaxies are dwarfed by the voids around them, your curiosity naturally drifts outward again, away from the rare giants, away from the familiar lights, toward the immense, silent distances that separate everything from everything else. And it is there, in those stretches of near nothingness, that the next layer of the universe quietly waits to be understood. And so your attention drifts outward, almost involuntarily, away from the rare giants and their extended halos of starlight, and into the spaces between them. Because once you truly absorb how small even the largest galaxies are, once you let go of the instinct to see them as the main characters of the universe, another realization rises quietly to the surface. The universe is not defined by what it contains. It is defined by what separates those things, by distance, by absence, by the vast, patient emptiness that stretches between every island of matter. At first, this emptiness feels like a void in the emotional sense, something lacking, something unfinished. We are not comfortable with it. We prefer substance. We prefer objects. We like to point and name and describe. But the universe does not share that preference. By volume, it is overwhelmingly empty. Not just mostly empty, but almost entirely so. Galaxies, even the largest ones, occupy a vanishingly small fraction of cosmic space. The rest is distance, silence, darkness. Consider the average separation between galaxies. Even in relatively crowded regions, galaxies are typically millions of light years apart. Millions. Light, racing at the ultimate speed limit of the universe, still takes millions of years to cross the gulf between one luminous structure and the next. And this is not an exception. This is the norm. From the perspective of scale, galaxies are lonely things. They drift through space with immense buffers of nothingness between them. This is difficult to internalize because our everyday experience offers no analogy. On Earth, emptiness is rare. Air fills every room. Matter surrounds us. Even the spaces between objects are occupied by something. But in the universe, emptiness is the default state. Matter is the intrusion. And once you see it this way, once you invert your assumptions, the cosmos begins to feel profoundly different. Imagine shrinking the universe down to a size you could walk across. Let us say you compress everything so that 1 billion light years becomes a kilometer. On that scale, a typical galaxy would be smaller than a grain of sand, and the distance between galaxies would be measured in meters. Long stretches of bare ground with nothing on them at all. You could walk for minutes without encountering a single speck of matter. The universe would look less like a crowded city and more like an endless desert, dotted with rare, delicate grains. And yet, even this analogy struggles to capture the truth, because it still relies on a surface, a ground, a backdrop. In reality, space itself is the stage, and it extends in all directions. The emptiness is three-dimensional, immersive, enveloping. There is no edge to lean against, no horizon you can reach, just more distance. What makes this emptiness even more striking is how little of it is ever acknowledged in popular depictions of the universe. We see images filled with galaxies, clusters, filaments of light, but those images are carefully framed. They zoom in, they enhance contrast, they reveal structure. They rarely show you the overwhelming majority of space that contains nothing visible at all. Because if they did, the image would appear almost blank. And perhaps that blankness feels unsatisfying. Perhaps it feels like a failure of imagination. But it is not. It is the most honest portrait of the universe we could offer. The vast spaces between galaxies are not simply empty in the casual sense. They are regions where matter density drops to nearly zero. A few stray atoms drift through cubic meters of space. Radiation passes silently. Dark matter flows invisibly. But compared to the luminous regions we focus on, these spaces are barren. They are cosmic deserts on a scale that dwarfs any desert on Earth. And yet, these empty regions dominate the universe. They are the rule, not the exception. If you were to randomly select a point in space, the probability that it lies within a galaxy is essentially zero. Almost every location is intergalactic. Almost every cubic meter of the universe is far removed from stars, planets, and light. This realization can feel disorienting. We have built our understanding of the cosmos around objects, around things. But the true architecture of the universe is defined by distance. The separation between structures is not a secondary detail. It is the main feature. Even when galaxies gather into groups or clusters, the emptiness persists. A galaxy cluster may contain hundreds or thousands of galaxies, but it also spans tens of millions of light years. The galaxies do not fill that volume. They barely scratch it. They remain isolated, each surrounded by its own sphere of emptiness. From within a cluster, the universe would still feel vast and quiet. Neighboring galaxies would be distant smudges, not looming presences. And when we move beyond clusters, the emptiness deepens further. The space between clusters can be hundreds of millions of light years across. These are not gaps you casually cross. They are immense voids where gravity has gathered matter elsewhere, leaving behind regions of profound sparsity. In these voids, galaxies are exceedingly rare. Light is scarce. The universe becomes almost featureless. It is tempting to think of these voids as holes, as absences carved out by some process. But that framing is misleading. The voids are not missing something. They are simply regions where matter never accumulated in the first place. The universe began nearly uniform, with tiny fluctuations in density. Over time, gravity amplified those fluctuations. Matter flowed towards slightly denser regions, leaving behind vast expanses that grew ever emptier. The voids are not anomalies. They are the natural outcome of cosmic evolution. And in a strange way, they give meaning to structure. Without emptiness, there would be no contrast, no pattern, no sense of scale. Galaxies shine because they are rare. Clusters impress because they are exceptions. The universe derives its drama not from abundance, but from scarcity. This is why the distances between galaxies matter so much. They remind us that the universe is not a packed collection of objects, but a sparse network. They force us to confront the fact that most of existence unfolds far from any star, that most of space-time is cold, dark, and silent. And yet, there is beauty in that silence, a kind of cosmic minimalism. The emptiness is not hostile. It is simply indifferent. It allows light to travel unimpeded for millions of years. It preserves the echoes of ancient events. It provides the canvas on which structure slowly emerges. There is also a philosophical weight to this realization. If the universe is mostly empty, then our presence within a galaxy is extraordinarily rare. Not privileged in the sense of importance, but remarkable in the sense of improbability. We exist in one of the few places where matter has gathered densely enough to form stars, planets, chemistry, and eventually thought. The emptiness makes that concentration all the more striking. And yet, even that concentration does not challenge the dominance of space. A galaxy, no matter how large, is a thin smear of matter suspended in a vast volume of nothing. Its stars are separated by light years. Its outer edges fade gradually into darkness. Its influence diminishes quickly beyond its gravitational reach. It does not fill space, it barely occupies it. This becomes especially clear when we try to imagine the universe as a whole. If we could see all galaxies at once, plotted in their true positions with accurate distances, the map would look almost empty, points scattered across a black expanse, vast regions with no points at all. The eye would be drawn not to the points, but to the spaces between them. And perhaps that is the ultimate lesson of cosmic scale. The universe is not a place crowded with things. It is a place defined by distance, by separation, by the quiet, persistent dominance of emptiness. As this understanding settles in, another layer of curiosity begins to form. Because if galaxies are separated by such immense distances, if emptiness is the primary feature of the cosmos, then what happens when galaxies do gather? When gravity overcomes separation and pulls them into larger associations? When isolation gives way, not to contact, but to proximity on a grand scale? There are places in the universe where galaxies are closer together, where their mutual gravity binds them into vast families. Not close by human standards, not touching, not colliding constantly, but close enough that their fates become linked. These are the clusters of galaxies, structures that stretch across tens of millions of light years, containing hundreds or thousands of galaxies drifting together through space. And once you have truly grasped how empty the universe is, how immense the distances between individual galaxies can be, you are ready to appreciate just how extraordinary those clusters are. Not because they are dense, but because even at their densest, they remain mostly empty. They are islands of relative closeness in an ocean of separation. And understanding their true scale requires carrying forward everything you have learned about distance, emptiness, and proportion. So your imagination, now tempered by the vastness of the void, begins to turn gently toward those gatherings of galaxies, toward the places where isolation softens into community, and where scale once again reshapes your intuition. The emptiness does not disappear there. It never does. But it takes on a different role, framing the next level of cosmic structure and inviting you to look even deeper into the architecture of the universe. And so, with the immensity of the void still lingering in the background of your thoughts, something shifts. Because even in a universe defined by separation, gravity is patient. It works slowly, relentlessly, across millions and billions of years, drawing isolated islands a little closer together. Not close in any human sense, not enough to erase the emptiness, but close enough that isolation gives way to association. This is where galaxy clusters quietly enter the story, not as dense cities of matter, but as subtle gatherings spread thinly across truly enormous regions of space. A galaxy cluster is, at first glance, an idea that seems to contradict everything you have just absorbed. After all that emphasis on emptiness, on separation, on vast gulfs of nothing, the word cluster suggests crowding. It implies proximity. It hints at something packed and busy. And yet, once again, the universe asks you to recalibrate your expectations. Because clusters are not crowded in the way your intuition imagines. They are crowded only by cosmic standards, and those standards are mercilessly vast. A typical galaxy cluster stretches across tens of millions of light years. Some are smaller, some far larger, but all of them dwarf individual galaxies completely. Within this immense volume, hundreds or even thousands of galaxies drift together, bound by their mutual gravity. From a distance, from the perspective of a telescope compressing scale into a single image, a cluster can look dense. Galaxies appear close, almost touching, but this is an illusion born of projection. In three-dimensional space, the distances remain enormous. Each galaxy retains its personal bubble of emptiness. Collisions are rare, unfolding over timescales so long that they feel almost frozen in time. If you could place yourself inside a cluster, standing on a hypothetical vantage point somewhere between its galaxies, the experience would be profoundly underwhelming. The nearest galaxy might still be millions of light years away. Its light would arrive as a faint smudge, barely brighter than the surrounding darkness. The sky would not be filled with looming spirals. It would be mostly black, punctuated by distant points. Even here, in one of the densest environments the universe offers, emptiness reigns supreme. And yet, clusters matter deeply. They are not mere collections of galaxies. They are gravitational ecosystems. Their combined mass, dominated not by stars but by dark matter, warps spacetime itself. Light passing through a cluster bends, distorts, magnifies. Background galaxies appear stretched and smeared by gravitational lensing, revealing the invisible scaffolding that holds the cluster together. In this way, clusters become laboratories, places where the fundamental components of the universe reveal themselves indirectly. What is striking, perhaps even counterintuitive, is how little of a cluster's mass resides in the galaxies themselves. Stars account for only a small fraction. Most of the ordinary matter is found in vast clouds of hot gas filling the space between galaxies. This gas is so diffuse that it would be classified as a vacuum by earthly standards, and yet it glows brightly in X-rays because of its enormous temperature. Trillions of degrees of energy spread thinly across millions of light years. Once again, size does not imply density, it implies extent. Surrounding all of this is dark matter, invisible and dominant. It forms the deep gravitational well that defines the cluster's shape and motion. Galaxies orbit within this well like leaves caught in a slow, cosmic eddy. Their paths are long and graceful, their interactions gentle and rare. Time stretches inside a cluster. Processes that would seem dramatic elsewhere unfold with glacial patience here. And beyond clusters lie superclusters, even larger arrangements that challenge the very idea of structure. Superclusters can span hundreds of millions of light years. They are loose, elongated, often filamentary. Unlike clusters, they may not be fully gravitationally bound. They are more like suggestions than objects, regions where matter is slightly more concentrated than average, tracing out patterns on the largest scales we can observe. At this level, the universe begins to feel less like a collection of things and more like a texture. Clusters become nodes. Superclusters become regions. The distinctions between object and background start to blur. You are no longer talking about galaxies as entities, but about distributions, about probabilities, about gentle variations in density across an almost incomprehensible expanse. And still, even here, emptiness dominates. A supercluster may sound enormous, and it is, but it occupies only a tiny fraction of the volume it spans. Most of that space contains nothing visible at all. The galaxies trace out a loose skeleton, leaving vast cavities between them. The universe does not fill itself, it sketches. This is perhaps the most challenging lesson of cosmic scale. Density is relative, crowding is contextual. A galaxy cluster, the densest environment most galaxies will ever experience, is still more than 99.99% empty by volume. Matter remains the exception. Space remains the rule. And yet, there is something deeply moving about these gatherings. Not because they defy emptiness, but because they reveal how structure emerges despite it. Gravity, given enough time, can coax matter into patterns across astonishing distances. It can weave galaxies into families, clusters into networks, superclusters into sprawling arrangements that stretch across the observable universe. The emptiness does not prevent structure. It frames it. From this perspective, clusters are milestones in the cosmic story. They represent a step up in scale, a transition from individual galaxies to collective behavior. Within a cluster, galaxies influence one another subtly. Gas can be stripped. Star formation can be quenched. Orbits can be altered. The environment matters, not dramatically, not violently, but persistently. And when clusters interact with one another, when they collide and merge, the scale of the event defies ordinary language. Two clusters, each spanning tens of millions of light years, pass through each other over billions of years. Galaxies glide past like ghosts. Gas clouds collide and shock, heating further. Dark matter sails through almost unaffected. These collisions leave imprints that persist for eons, ripples frozen into the structure of the universe. Yet even these colossal events do not challenge the dominance of emptiness. They unfold within it. They are softened by it. The universe remains spacious, even when its largest structures interact. As you hold all of this together, the picture becomes clearer, if not simpler. Galaxies are small. Clusters are large but sparse. Superclusters are larger still, but looser. At every level, space outweighs matter. And at every level, scale humbles intuition. This naturally leads the mind to wonder whether there is an ultimate pattern, something that ties clusters and superclusters together into a coherent whole. Because if galaxies gather into clusters, and clusters arrange themselves into larger regions, then perhaps the universe has an underlying architecture that extends even further. A structure not defined by objects, but by connections. And this is where the story begins to stretch again, beyond clusters and superclusters, into something more abstract and more profound. Because when astronomers map the distribution of galaxies across hundreds of millions of light years, they do not see randomness. They see filaments, threads of matter stretching across space, intersecting at dense nodes, enclosing vast empty regions. A cosmic web, faint and intricate, spanning the observable universe. Once you are ready to see clusters not as endpoints but as intersections, once you accept that even these immense gatherings are just features within a larger pattern, your imagination naturally drifts outward again, toward that web-like structure that underlies everything we have discussed so far, toward the grandest map the universe offers, where galaxies, clusters, and superclusters reveal themselves not as isolated marvels, but as tiny knots woven into an immense, dark tapestry that stretches far beyond any single scale we have yet considered. And once you allow yourself to see clusters not as isolated monuments but as intersections, as meeting points in a much larger arrangement, the universe begins to reveal a pattern that is at once subtle and overwhelming. This is the moment where the cosmos stops looking like a scattered collection of things and starts to resemble a living map. a structure not drawn with lines or borders, but traced gently by gravity over billions of years. This is where the idea of the cosmic web quietly takes hold. Imagine, for a moment, pulling back even farther than before, far beyond individual clusters, far beyond superclusters. You let your perspective drift outward until millions upon millions of light years compress into something your mind can almost hold. And then, slowly a shape emerges. Not a solid shape, not a surface or a sphere, but something more delicate: filaments. Vast, thread-like concentrations of matter stretching across hundreds of millions of light years, weaving their way through space like faint veins in a nearly transparent body. Along these filaments, galaxies gather. Not evenly, not randomly, but preferentially. They line up along these invisible strands, flowing slowly toward denser regions, toward nodes where filaments intersect. Those intersections become clusters. The filaments between them glow faintly with galaxies too sparse and dim to stand out individually. And between the filaments lie enormous voids, regions so empty that even dwarf galaxies are rare. This is the true large-scale structure of the universe. Not a uniform fog of matter, but a vast, three-dimensional web suspended in darkness. What is striking is how thin these filaments are compared to the space they traverse. Even though they may stretch across hundreds of millions of light years, their thickness is small relative to the cosmic expanse. They are delicate, almost fragile, yet they define the architecture of everything we see. Galaxies are not sprinkled randomly through space. They are beads threaded onto these cosmic strings, their positions guided by gravitational currents set in motion when the universe was young. This pattern did not arise quickly. In the early universe, matter was distributed almost uniformly, with only tiny fluctuations in density. Those fluctuations were minute, barely noticeable, but gravity is patient. Over time, slightly denser regions pulled in more matter, growing denser still. Slightly emptier regions lost matter, becoming emptier. This slow amplification continued for billions of years, stretching and sharpening the initial randomness into a vast network. The cosmic web is not imposed from outside. It is an emergent structure, grown organically from simple beginnings. And perhaps that is what makes it so compelling. The same laws that govern the fall of an apple shape the distribution of galaxies across the observable universe. There is no guiding hand arranging filaments and voids. There is only gravity acting everywhere all the time, sculpting matter into patterns that span scales beyond imagination. From within a galaxy, or even within a cluster, this structure is invisible. You cannot see the cosmic web by looking up at the night sky. The distances are too great, the filaments too faint. It is only when astronomers map the positions of millions of galaxies that the pattern emerges. Dots on a map, when viewed individually, mean little. But taken together, they trace out an unmistakable network, a skeleton of the universe itself. And yet, even this web-like structure does not fill space. The filaments occupy only a small fraction of the cosmic volume. The voids between them are immense. Some stretch across hundreds of millions of light years, nearly devoid of galaxies. If you were to find yourself in one of these voids, the universe would feel profoundly empty. The nearest galaxy might be tens of millions of light years away. The sky would be dark, almost featureless. The cosmic web, for all its grandeur, emphasizes once again that emptiness is the dominant condition. There is something deeply humbling about this realization. We tend to imagine the universe as rich and crowded because we focus on what shines. But the cosmic web teaches us that structure is sparse, that matter is concentrated along narrow paths, leaving vast regions untouched. It is a reminder that significance does not come from ubiquity. It comes from pattern. The filaments themselves are not solid objects. They are regions where matter density is slightly higher than average. They contain galaxies, gas, and dark matter, all flowing slowly along gravitational gradients. Over time, material moves along these filaments toward clusters, like water draining into basins. The process is slow, almost imperceptible on human timescales, but relentless. The universe is still evolving. The web is still tightening. And dark matter plays the starring role here. Long before stars ignited, dark matter began to clump, forming the initial scaffolding of the web. Ordinary matter followed, drawn into these invisible wells. The galaxies we see today are tracers, highlighting the underlying structure that we cannot see directly. In this sense, The luminous universe is a map of something deeper, something hidden. When you step back and consider the cosmic web as a whole, the scale becomes almost dizzying. Filaments stretching across hundreds of millions of light years, nodes separated by similar distances, voids larger than any structure we have yet discussed. And yet, all of this fits within the observable universe, a region with a diameter of tens of billions of light years. Even the web itself is a small thing compared to the whole. This is where intuition truly begins to fail. Because at this scale, familiar concepts like near and far lose their meaning. A filament hundreds of millions of light years long is both enormous and insignificant, depending on your frame of reference. It is enormous compared to a galaxy, insignificant compared to the observable universe. Scale becomes contextual. Perspective becomes everything. And there is a strange beauty in that. The cosmic web is not just a structure. It is a story about emergence, about how simple rules give rise to complexity, about how order can arise without intention. It is a reminder that the universe does not need to be crowded to be rich. It can be sparse and still intricate. When we speak of galaxies as nodes in this web, the language is not metaphorical. They truly are intersections, places where filaments meet and matter accumulates. But those nodes are tiny compared to the web itself. Even clusters, massive as they are, occupy only a small volume within the larger pattern. They are like knots in a vast net, noticeable only because we look closely, and this brings us back, once again, to the question of scale. If galaxies are small compared to clusters, and clusters are small compared to filaments, and filaments are thin compared to the voids they enclose, then what does it mean to say that something in the universe is large? Large relative to what? Significant on which scale? The cosmic web reframes the entire discussion. It tells us that size is not absolute, that prominence is relative, that what feels immense at one level dissolves into subtlety at another. It invites humility. It asks us to constantly adjust our mental zoom, to resist the temptation to settle into any single perspective. And perhaps most profoundly, it reminds us that we live inside this web. The Milky Way is not isolated. It sits on a filament, part of a larger flow of matter stretching far beyond our local group. Our cosmic address is not just a galaxy or a cluster, but a position within this vast network. We are inhabitants of a node on a thread, suspended in an architecture that spans the observable universe. As you hold this image in your mind, the universe begins to feel both larger and more intimate. Larger because the structures extend far beyond anything we can traverse or fully comprehend. More intimate because they are connected. Nothing exists in complete isolation. Every galaxy is part of a pattern. Every cluster is a consequence of flows that began billions of years ago. And yet, even the cosmic web is not the end of the story. Because once you grasp its scale, once you see how galaxies become mere points within it, another question naturally arises. How does this entire structure fit within the observable universe as a whole? How small is even the web itself when placed against the full diameter of what we can see? If we take all of this structure, every filament, every node, every void, and place it inside the observable universe, what fraction does it occupy? How does the scale of galaxies compare not just to clusters or filaments, but to the full cosmic horizon? Because there is one more step outward, one final recalibration of perspective, waiting quietly ahead. A step that reduces everything we have discussed so far to something almost vanishingly small, and invites us to confront, once again, just how astonishingly vast the universe truly is. And so the mind, already stretched thin by filaments hundreds of millions of light years long, is invited to take one final, almost vertiginous step backward. You have followed the trail from stars to galaxies, from galaxies to clusters, from clusters to filaments, until the universe no longer feels like a collection of objects at all, but like a faint architecture suspended in darkness. And now comes the question that quietly dissolves even that sense of structure. How does all of this fit inside the observable universe itself? What happens to galaxies, to clusters, to the entire cosmic web, when you place them against the full span of what we can see? The observable universe has a size that defies instinct in a way that even the cosmic web does not quite manage. It stretches across tens of billions of light years, not because it is the whole universe, but because it is the region from which light has had time to reach us since the beginning of cosmic expansion. It is a horizon defined not by walls or edges, but by time itself. And within that immense sphere, everything we have talked about so far exists. Every galaxy, every filament, every void. All of it fits comfortably inside a volume that, when viewed with the right perspective, makes even the largest structures feel astonishingly small. This is where numbers begin to lose their emotional weight. You can say that the observable universe is roughly 93 billion light-years across. You can write it down. You can repeat it. But your intuition refuses to cooperate. The difference between a million, a billion, and tens of billions collapses into a vague sense of largeness. And so the universe slips past your defenses once again, hiding its true scale behind familiarity with words. Let us try gently to coax intuition back into the conversation. Imagine the observable universe as a vast map spread out before you. Not a detailed map, not one filled with stars and glowing clouds, but a clean, honest one. The entire diameter is laid out from one side to the other. Now place a galaxy like the Milky Way onto that map. Not enlarged, not emphasized, placed at its true relative size. It vanishes. Even if you strain your eyes, even if you know exactly where to look, it occupies a fraction of the width, something like a 10 millionth of the diameter, less perhaps. On this scale, the Milky Way is not a disk or a spiral. It is not even a dot. It is an idea smaller than a pixel. And if you were to add 1,000 galaxies together, clustering them tightly, they would still fail to claim a visible presence. They would merge into a suggestion of darkness on darkness. This is not an exaggeration. It is a consequence of honest scaling. Galaxies feel large because we live inside one. They feel significant because all our stories unfold there. But the universe does not privilege our perspective. It does not enlarge our home for convenience. It simply places it where it belongs, as one tiny concentration of matter among countless others. And once you see this, once you truly allow yourself to imagine the Milky Way reduced to a near mathematical abstraction on a universal map, something profound happens. The cosmic web itself begins to shrink. Those filaments that once felt impossibly long now trace faint lines across the map, barely thicker than hairline cracks. Clusters collapse into points along those lines. Voids dominate the image, vast blank regions where almost nothing happens at all. The observable universe, viewed this way, is not crowded. It is almost empty. Structure exists, yes, but it is sparse, delicate. The overwhelming impression is not of abundance, but of restraint. The universe is mostly space, mostly distance, mostly silence. And this silence is not evenly broken. Evenly spaced galaxies would still feel crowded compared to reality. Instead, matter clings to itself in thin threads, leaving enormous volumes untouched. If you could randomly choose a direction and travel across the observable universe, the chances of passing near a galaxy would be vanishingly small. Most of your journey would unfold in darkness, far from any star, far from any source of light. This is where the phrase small in an astonishing way becomes meaningful. Galaxies are not just small compared to the universe. They are almost negligible. They matter deeply to us because we are bound to one, but cosmically speaking, they are minor features. Decorations on a vast canvas. Flecks of paint scattered across an enormous surface. And yet, there is no sense of dismissal here. No implication that galaxies are unimportant. On the contrary, their smallness makes their existence more remarkable, not less. That matter can gather. That complexity can arise. That stars can ignite and planets can form, all within such tiny pockets of an overwhelmingly empty universe, is extraordinary. The observable universe reframes the entire discussion. It tells us that when we speak of large galaxies, or even the largest galaxies ever observed, we are speaking locally. Large within a narrow context. Against the full span of cosmic distance, all galaxies are small. Uniformly so. There are no exceptions at this level. Even the rare giants dissolve into insignificance. And this brings with it a subtle but important shift in how we think about maps of the cosmos. When we see images showing thousands of galaxies packed together, we are seeing an artistic compromise, a necessary one. If those galaxies were shown at their true relative sizes, the image would be nearly blank. The structures we celebrate would be invisible. The universe would appear empty, and we might mistake that emptiness for absence rather than scale. So astronomers stretch and exaggerate and color and enhance, not to deceive, but to communicate, to make the invisible visible. to help our limited intuition engage with something far beyond its comfort zone. But the cost of that communication is distortion, and unless we consciously undo it in our minds, we carry those distortions forward, imagining galaxies as far larger and more dominant than they truly are. On the scale of the observable universe, galaxies do not fill space. They barely punctuate it. They are statistical outliers in a sea of nothingness. And even when taken collectively, even when you count hundreds of billions of them, their combined volume remains negligible. Space wins every time. This realization can feel unsettling. It challenges our sense of importance. It asks us to accept that the universe is not built around things, but around distance. That matter is rare. That light is precious. That complexity is confined to tiny islands adrift in an ocean of emptiness. But there is also a quiet comfort in this view. Because if galaxies are so small, if they occupy such a tiny fraction of the universe, then their fragility becomes meaningful. They are precious precisely because they are rare. They are special not because they dominate, but because they endure. And it also invites a deeper kind of wonder. The universe did not need to form galaxies at all. It could have remained smooth, diffuse, uneventful. Instead, it allowed matter to clump, to organize, to light up small regions with stars and chemistry in motion. Those regions may be tiny on the grandest scale, but they are enough to host everything we know. When you look at the observable universe this way, perspective shifts again. The cosmic web is no longer the main character. It becomes a subtle texture within an even larger silence. The voids expand, the horizon recedes. Everything becomes smaller, quieter, more delicate, and yet the universe does not feel diminished by this. It feels more honest, more restrained, more profound. Grandeur, at this scale, does not come from size alone. It comes from contrast, from the fact that something exists at all within so much nothing. As your imagination lingers here, holding the entire observable universe in a single mental frame, another question begins to whisper at the edge of thought. If galaxies are this small compared to the whole, if even clusters and filaments fade into near invisibility, then what about the spaces that dominate this map? The regions that remain empty even on the largest scales? We have spoken of voids before, but only as gaps between filaments, as secondary features. But on the scale of the observable universe, these voids are not secondary at all. They are the majority, enormous regions tens or hundreds of millions of light years across, containing almost nothing, shaping the universe by their absence as much as matter shapes it by its presence. And once you have truly grasped how small galaxies are within the observable universe, you are ready to confront those voids directly. Not as empty mistakes, not as leftovers, but as fundamental features of cosmic structure. Features so vast that they make even the cosmic web feel delicate by comparison. And it is toward those immense, silent regions that the story now begins to drift as scale stretches intuition one last time, and emptiness reveals itself not as a lack, but as the dominant architecture of the universe. And so the mind drifts, almost inevitably, into the quietest regions of all. Beyond the filaments, beyond the clusters, beyond even the comforting idea that structure, however faint, is everywhere. Because once you have seen how small galaxies are within the observable universe, once you have accepted that even the cosmic web itself is a delicate pattern stretched thin across immensity, there is one comparison that changes everything. Galaxies set not against other galaxies, not against clusters or filaments, but against the vast cosmic voids that dominate the universe by volume. Cosmic voids are not empty in the casual sense. They are not holes punched into an otherwise solid universe. They are regions where matter never fully gathered, where gravity gently lost the competition, where density fluctuations faded instead of growing, and they are enormous, truly enormous. Some voids span 100 million light years. Others stretch to 200 or even 300 million light years across. Distances so large that even clusters of galaxies would fit comfortably inside them with room to spare. Now pause there for a moment. Let that comparison settle. A galaxy cluster, itself tens of millions of light years wide, reduced to a small feature inside a single void. A void so large that light takes hundreds of millions of years to cross it. And inside that void, almost nothing happens. A few isolated galaxies may drift near the edges. Perhaps a faint filament threads its way through. But the overwhelming majority of the volume is silent, dark, sparse beyond imagination. This is where scale delivers its most humbling lesson. Because when you place a galaxy inside a cosmic void, the galaxy does not merely become small, it becomes negligible, like a grain of sand lost in a stadium, not placed carefully on the field, but dropped somewhere in the stands, almost impossible to find again. And even that analogy struggles, because a stadium is still filled with air, with sound, with boundaries. A cosmic void has none of that. It is space in its purest form. We often speak of galaxies as islands in space, but cosmic voids reveal how generous that metaphor really is. An island implies proximity to others, a shared ocean, a sense of belonging to a larger geography. A galaxy in a void is more like a single atom drifting in a volume larger than any structure we have discussed so far. It is not just isolated, it is dwarfed. And yet, these voids are not rare. They are the dominant feature of the universe on large scales. Most of the observable universe is composed of voids. The filaments and clusters that catch our eye are the exceptions, the outlines, the boundaries. The voids are the background, the negative space that gives the cosmic web its shape. This inversion of perspective is deeply unsettling for the human mind. We are trained to focus on objects, on things we can point to and name. But the universe is telling us, again and again, that what matters most by volume is absence. The largest structures are defined not by what is there, but by what is not. Imagine for a moment trying to map the universe by marking only the voids. Instead of dots for galaxies, you shade regions where matter is scarce. The resulting image would be dominated by enormous contiguous areas, with thin, irregular boundaries where matter has collected. The cosmic web would appear not as a network of filaments, but as the edges of vast empty bubbles pressing against one another. In this view, galaxies are not the main feature at all. They are the residue, the leftover matter that gravity managed to gather along the edges of emptiness. Structure emerges not because matter fills space, but because it avoids certain regions, draining away toward others. This perspective changes how we think about size entirely. A galaxy that feels large when compared to another galaxy becomes irrelevant when compared to a void. Even the largest galaxy ever observed, with its million light-year span, is swallowed whole by a void 100 times larger. It does not define the void. It barely interrupts it, and the voids themselves are not uniform. Some are nearly empty, containing only a handful of faint galaxies. Others are slightly richer, threaded with weak filaments. But all share a common trait. They are regions where gravity lost, where initial density fluctuations were just a little too small to grow, where matter slowly drifted away, leaving behind a growing emptiness. There is something almost poetic in that. The universe, which we often imagine as a place of dramatic forces and violent events, is shaped just as much by what did not happen as by what did. A tiny difference in density billions of years ago determines whether a region becomes a cluster of galaxies or a vast void. The universe remembers those differences. It preserves them on scales so large that our minds struggle to keep them distinct. And here, perhaps, is the most startling comparison of all. Some cosmic voids are larger than superclusters, larger than the largest gatherings of galaxies we know. They are not secondary features. They rival the biggest structures in the universe in size, and exceed most of them. In terms of sheer volume, voids are the giants. This forces us to reconsider what we mean when we talk about the largest things in the universe. If size alone were the criterion, voids would claim the title. Not galaxies, not clusters, not filaments. The universe is dominated by regions defined by scarcity, not abundance. Yet we rarely celebrate voids. They do not glow. They do not host dramatic events. They do not produce images that grace magazine covers. They are difficult to study precisely because they are so empty. And so they slip into the background of our narratives, mentioned briefly, then set aside. But voids are not passive. They shape the universe just as much as matter does. As regions empty out, they expand faster than denser regions. They push matter toward their edges. They help stretch filaments and sharpen clusters. In this way, voids actively participate in cosmic evolution, even though they contain so little. If you could watch the universe evolve over billions of years and fast forward, you would see voids grow. Not because something is added to them, but because matter leaves. They swell as galaxies and gas drift outward, pulled toward denser regions elsewhere. The universe becomes increasingly structured, not by filling space, but by emptying it. And this brings us back, once again, to galaxies. When placed inside this context, galaxies take on a new identity. They are not the universe. They are not even its dominant features. They are concentrations along boundaries, points where matter has pooled at the edges of vast emptiness. Their smallness is not a flaw. It is a consequence of cosmic architecture. Picture a single galaxy suspended in a void. Its stars orbit quietly. Its internal dynamics unfold as they always have. From within, nothing feels different. The galaxy does not know it is small. It does not know it is surrounded by emptiness on a scale beyond imagination. Its stars burn. Its planets form. Its history continues. Scale does not matter locally. And yet, from the outside, from a perspective that embraces the void around it, the galaxy becomes almost absurdly tiny, a speck within a region that could swallow entire superclusters. A reminder that significance is always contextual. There is a subtle philosophical lesson here. We often equate size with importance. We assume that larger structures matter more, that they define the universe. But the voids challenge that intuition. They are large, yes, but they are defined by absence. They matter not because of what they contain, but because of how they shape everything else. In this sense, voids and galaxies are two sides of the same coin. One is presence, the other is absence. One shines, the other remains dark. And together, they define the universe's large-scale structure. When we compare a galaxy to a cosmic void, the imbalance is staggering. The galaxy occupies an infinitesimal fraction of the void's volume. If the void were scaled to the size of a football stadium, the galaxy would be smaller than a grain of dust floating somewhere in the air. Not on the field, not on the seats, just suspended, almost impossible to locate. And yet, it is within that grain of dust that complexity arises: stars, chemistry, life, thought. The void, for all its size, hosts none of that. It is vast, but it is simple. The galaxy is tiny, but it is rich. This contrast may be the most profound of all. The universe reserves its complexity for its smallest regions. It spends its volume on emptiness. The things we care about happen in places that barely register on a cosmic map. As you sit with this realization, the universe begins to feel both colder and more intimate. Colder because of the overwhelming dominance of voids. More intimate because of how precious and rare the regions of structure truly are. And once again, the story leans forward. Because if voids are so large, if they dwarf galaxies and even clusters, then they must play a role in how the universe appears to us. They must influence what we see and what we miss. They must shape our perception, not just our maps. Light travels differently through emptiness than through matter. Bright regions draw attention. Dark regions recede. Our brains, tuned to notice contrast and pattern, assign importance to what stands out, not to what dominates by volume. And this sets the stage for the next subtle illusion the universe presents to us. Because even though voids are the giants of cosmic scale, they are almost invisible to intuition. We do not feel their size. We do not notice their presence. Instead, our perception is drawn to light, to structure, to brightness. And that brightness can deceive us into thinking that galaxies are larger, more dominant, more significant than they truly are. This is where the next layer of the story begins to take shape. The realization that light itself, the very thing we rely on to understand the universe, can mislead us about scale. That brightness exaggerates importance, that darkness hides vastness, and that to truly understand the size of galaxies, we must confront not just distance and emptiness, but the way our perception assigns meaning to what we see. And so, gently, almost without warning, the narrative shifts again. Away from voids as structures, and toward the subtle trick played by luminosity itself. Toward the idea that galaxies appear large not because they are, but because they shine. And that what we ignore, what we fail to see, may in fact be the largest thing of all. And here is where the universe performs one of its quietest, yet most effective illusions. After all the talk of distance and emptiness, of voids vast enough to swallow clusters whole, it would be reasonable to expect that our perception might finally align with reality. That we would instinctively feel how small galaxies truly are. But that does not happen. Instead, light steps in and gently deceives us. You see, the human mind is not built to measure space. It is built to respond to brightness. From the moment our ancestors first opened their eyes, light meant safety. warmth, information. Darkness meant uncertainty. And so, over countless generations, our brains learned a simple rule. What shines is important. What is dark can be ignored. And that rule, which serves us well on Earth, becomes profoundly misleading when applied to the universe. Galaxies shine. They glow with billions of stars, with nebulae lit from within, with energetic processes unfolding across immense distances. And because they shine, our minds assign them weight, presence, size. We see a luminous spiral against a black background and instinctively think, this is large, this is dominant, this is the universe. But that impression is an illusion created by contrast, not by scale. Imagine standing in a vast, pitch-dark desert at night. Far away, a single city glows on the horizon. From where you stand, that city feels immense. It dominates your field of view. Your attention is drawn to it immediately. And yet, you know that the city occupies a tiny fraction of the landscape around it. The darkness between you and the lights is far larger, but your eyes slide past it without registering its size. The same thing happens when we look at the cosmos. Galaxies appear large because they emit light. The universe appears filled because our instruments detect photons. But light is a terrible guide to volume. It tells us where energy is being released, not where space exists. And space, not light, defines scale. This is why galaxies can appear to fill images of the universe, even though they occupy almost none of it. When astronomers create deep field images, they often reveal thousands of galaxies packed into a tiny patch of sky. The image feels crowded, almost overwhelming. But what those images do not show is the distance between those galaxies. They are stacked along the line of sight, separated by billions of light years, compressed into a flat picture. Our eyes read that compression as density. Our brains mistake overlap for proximity. Brightness compounds this illusion. A galaxy that is faint but nearby can appear similar in size to a galaxy that is bright but distant. Our visual system struggles to disentangle these cues. We rely on apparent size and brightness to judge distance in everyday life. In the universe, those cues break down. A luminous galaxy far away can outshine a closer, smaller one. The result is a cosmic hall of mirrors where scale becomes ambiguous. And then there is the matter of structure. Galaxies have shape, spirals, bars, bulges, arms. Structure draws attention. It gives the eye something to latch onto. Void, by contrast, has no structure. It offers no pattern, no edges, no variation. And so the brain quietly filters it out. Even though voids dominate the universe by volume, they barely register in perception. This is not a flaw. It is a feature of how perception works. The brain is an efficiency machine. It highlights what changes, what contrasts, what carries information. Emptiness carries very little information, so it is suppressed. But in suppressing emptiness, we suppress scale itself. Consider how we talk about the universe in everyday language. We say it is filled with galaxies. We speak of a universe teeming with stars. We describe space as though it were crowded. These phrases feel natural because they align with what we see. But they are deeply misleading. The universe is not filled with galaxies. It is punctuated by them. They are rare interruptions in an otherwise continuous expanse of space. Light also misleads us temporally. When we look at distant galaxies, we see them as they were billions of years ago. Their light has been traveling through expanding space, stretched and diluted along the way. A galaxy that appears large and bright in our telescopes may no longer exist in that form. It may have merged, faded, or been torn apart. Light freezes moments in time and presents them to us out of context. We mistake these snapshots for present reality. There is also a psychological component. Humans are storytellers. We gravitate toward characters. Galaxies make good characters. They have shapes, histories, interactions. Void does not. Void has no obvious narrative. And so, unconsciously, we build our cosmic stories around what shines, what moves, what collides. We give galaxies starring roles and relegate emptiness to the background. But the background, in this case, is the main stage. Brightness exaggerates importance in another subtle way. The brightest regions of a galaxy often occupy a small fraction of its total extent. The core glows intensely. Star-forming regions flare with color. The outer regions fade gradually into darkness. When we see a galaxy image, our attention is drawn to the bright parts. We mentally define the galaxy by those luminous regions, ignoring the faint outskirts. And yet, those faint outskirts may extend far beyond what we visually register. This leads to an underestimation of emptiness even within galaxies. We imagine galaxies as dense collections of stars because we see the bright ones. We forget the vast spaces between them. We forget that most of a galaxy's volume is nearly empty. The same illusion repeats at every scale. There is an irony here. The more advanced our telescopes become, the more dramatic the illusion can feel. We see deeper, we see fainter, we reveal more galaxies, and each new image seems to show a universe more crowded than before. But what has really happened is that we have lowered the threshold of brightness we can detect. We are still seeing only the luminous islands, not the sea they float in. If we could build an instrument that visualized space itself rather than light, the universe would look profoundly different. Most of the image would be uniform, featureless. Only subtle variations would hint at where matter slightly perturbs space-time. Galaxies would not leap out. They would be minor ripples in a vast, smooth field. And this brings us back to the question of perceived size. Galaxies feel large because they are visible. Void feels small because it is invisible. But in truth, the opposite is closer to reality. Void is vast. Galaxies are tiny. Light flips that relationship in our minds. This illusion has consequences. It shapes how we imagine our place in the universe. We tend to think of ourselves as living in a busy cosmos, surrounded by countless neighbors, embedded in a rich tapestry of matter. And while that is true locally, it obscures the broader truth. We live on a tiny island, far from most others, adrift in a universe where isolation is the norm. Yet there is also something profoundly human in this deception. We cannot help but focus on light. It is how we understand the world. And perhaps the universe does not mind being misunderstood this way. Perhaps it allows us this illusion because it keeps us curious, because it gives us something to look at, something to wonder about, something to reach for. Still, if we want to understand scale honestly, we must learn to look past brightness. We must train ourselves to notice absence, to imagine distance where nothing is seen, to remember that every luminous dot is surrounded by an ocean of dark. When you do that, when you consciously subtract the light from your mental image, the universe becomes quieter, more spacious, almost austere. Galaxies shrink, clusters thin out, filaments fade into suggestion, and what remains is a sense of overwhelming emptiness, punctuated by rare sparks of complexity. This realization can be unsettling at first. It feels like something has been taken away. But in time, it becomes liberating, because it clarifies what truly matters. Complexity does not require abundance. Meaning does not require size. The universe does not need to be crowded to be profound. And once you see through the illusion of brightness, once you accept that light exaggerates size and importance, a new kind of understanding becomes possible. You can begin to imagine the universe not as it appears, but as it is scaled. You can ask different questions. Not how bright something is, but how much space it actually occupies. This naturally leads to a kind of mental experiment. What if we could shrink the universe down to a manageable scale, preserving true proportions? What if we could hold the cosmos in our hands, not as an artist's impression, but as an honest model? What would galaxies look like then? How small would they become? How much of the model would be empty? It is this thought experiment, this act of scaling the universe down without distortion, that offers perhaps the clearest insight of all. Because when you compress the universe faithfully, when you allow emptiness to dominate as it should, galaxies do not merely become small. They become almost absurdly tiny. And it is there, in that imagined miniature universe, that the next realization waits quietly. A realization about just how extreme the imbalance between matter and space truly is. About how, when scaled correctly, stars become smaller than grains of sand, galaxies smaller than dust, and the universe itself becomes a vast arena where emptiness does the heavy lifting. So the mind, now aware of how light has missiled it, begins to prepare for that final adjustment, the act of shrinking the universe down to human scale, not to make it familiar, but to make it honest. And as that image takes shape, the story moves gently forward toward a comparison so stark and so simple that it leaves little room for illusion at all. And so, with the illusion of brightness gently dismantled, with the realization settling in that light exaggerates importance while hiding scale, the mind is finally ready for the most honest experiment of all. Not a telescope, not a simulation, but a simple act of imagination. What happens if we shrink the universe down, carefully, faithfully, without artistic license, preserving the true proportions between matter and space? What if, just for a moment, we refuse to let light cheat on our behalf? Imagine the entire observable universe reduced to the size of something familiar. Not something tiny, but something human. Let us say a vast stadium, a place large enough to walk across, large enough to feel lost inside, but still graspable. The whole universe, every filament, every void, every galaxy, compressed into that single arena. Now ask yourself a quiet question. Where would matter be? At first, you might expect to see it everywhere. Perhaps scattered across the ground. Perhaps dusted lightly through the air. But that expectation is the last remnant of intuition resisting reality. Because when you scale honestly, when you preserve proportions instead of impressions, matter almost disappears. The solar system, which feels so expansive when we think of planets and orbits and distant, icy bodies, would shrink to something smaller than a grain of sand. Not placed carefully on the field, but lost in the texture of the surface itself. A single star, like our sun, would be smaller still, more like a bacterium. Something that exists, certainly, but something you would never notice unless you were specifically searching for it with a microscope. And a galaxy that contains hundreds of billions of stars, that spans 100,000 light years, that has inspired awe and mythology and decades of scientific effort. That galaxy would be reduced to a speck of dust, not a pebble, not a grain of rice, a dust particle, something that could float unnoticed in a beam of light, something you might brush away without realizing it was there at all. This is not poetry, it is proportion. Even a supercluster, a structure that stretches across hundreds of millions of light years, would not dominate the stadium. It would be smaller than a grain of pollen, barely visible, and the rest of the stadium, almost all of it, would be empty. Not just visually empty, but physically so. No matter, no stars, no galaxies, just space. And here is the moment where the mind tends to resist again. Because it feels wrong. It feels as though something important has been erased. Surely the universe must be fuller than this. Surely we have taken abstraction too far. But the numbers do not bend. The ratios do not care about comfort. This emptiness is not a consequence of exaggeration. It is the consequence of honesty. The universe, when scaled correctly, is not a place filled with things. It is a place where things are rare. Consider how dramatic that inversion is. All the stories we tell about the cosmos revolve around stars, galaxies, collisions, explosions. But those events unfold in regions that barely register on a true scale model. The vast majority of the universe does nothing at all. It simply exists as space, silent, cold, expanding. And yet, within those tiny specks of matter, everything meaningful happens. Nuclear fusion, chemistry, biology, consciousness, thought. The entire human story unfolds within a structure that, on a universal map, would be smaller than dust. There is something almost paradoxical about this. The universe devotes nearly all of its volume to emptiness, and almost none of it to complexity. And yet, complexity is what we notice, what we care about, what we study. Our attention is drawn not to what dominates, but to what defies domination. Imagine standing in that stadium, knowing that somewhere, suspended invisibly in the air or resting unnoticed on the ground, there is a dust speck that represents an entire galaxy. Every star, every planet, every potential life form, all compressed into something smaller than the eye can easily resolve. And now imagine thousands of such specks, millions, billions. Still, they would not fill the space. They would not coat the surface. They would not even make the stadium look dusty. The emptiness would remain overwhelming. This is the true scale of the universe. Not the one we feel when we look at glowing images, but the one that emerges when we force ourselves to honor distance and volume. And it does something subtle to our sense of meaning. Because if galaxies are this small, if they are this rare, then their existence becomes extraordinary. Not trivial, not expected, but remarkable. The universe did not need to allow matter to clump at all. It could have remained smooth, featureless, a vast, uniform expansion of particles drifting apart forever. Instead, through a delicate balance of forces, it allowed islands of structure to form. Tiny islands, yes, almost vanishingly small, but rich beyond measure. Think about what it means for a single star to ignite in such a universe. For gravity to gather enough matter in one place, against the general trend of expansion. to trigger nuclear fusion. That alone is improbable. To do it hundreds of billions of times within a single galaxy, and then to repeat that process across billions of galaxies, is nothing short of astonishing. And yet, even after all that, the universe remains almost entirely empty. This is where the metaphor of dust becomes powerful, not diminishing. Dust is easy to dismiss, but it is also where complexity hides. It carries information. It seeds structure. It is the residue of processes far larger than itself. Galaxies are dust not because they are insignificant, but because the universe is vast beyond any scale we evolved to comprehend. When you truly accept this, the language we use begins to feel inadequate. We say the universe is big, but big does not capture it. Big implies something filled, something bulky. The universe is not bulky. It is spacious, expansive, sparse. And galaxies are not large within it. They are intricate, dense with history, packed with events. But spatially, they are almost nothing. This perspective also reframes our place in the cosmos. We often ask whether humanity is small or insignificant. The universe answers that question with scale, not judgment. We are small, yes, but so is everything that matters. Size in the universe has no correlation with meaning. Life does not arise in voids hundreds of millions of light years across. It arises in tiny pockets of matter, on planets orbiting stars, within galaxies that barely register on a cosmic map. The universe spends its volume on emptiness, and its potential on rarity. There is also a strange comfort in this, because it means that meaning is not diluted by vastness. It is concentrated, precious. The fact that galaxies are dust specks does not make them trivial. It makes them special. And perhaps this is why the universe can feel so quiet, and yet so full at the same time. Quiet because most of it does nothing. Full because the parts that do something do it with extraordinary richness. As this scaled-down universe settles into your imagination, the final illusion falls away. There is no crowded cosmos. There is no sea of stars filling space. There are only rare, luminous islands in an ocean of nothing. And that nothing is not a flaw. It is the defining feature. And now, almost gently, another thought begins to form. If galaxies are dust, if stars are smaller than microbes, if the universe is an immense arena mostly devoid of matter, then perhaps size itself is not the right lens through which to judge cosmic importance. Perhaps the universe is not impressive because of how much there is, but because of how little is required to create something extraordinary. This realization does not close the story. It opens it. Because once you accept that smallness and significance are not opposites, a deeper question emerges. What does that smallness mean? What does it imply about our relationship to the universe? About the way we assign value, not just to cosmic structures, but to our own existence within them? Galaxies may be dust on the scale of the universe, but within that dust, the universe becomes aware of itself, and that tension between vast emptiness and concentrated meaning is not something to resolve. It is something to sit with. And as the mind rests there, in that quiet balance between scale and significance, the story naturally turns toward its final reflection. Not about size alone, but about what size does and does not tell us. About how smallness, far from diminishing wonder, may be the very thing that gives it depth. And so we arrive at a place that does not feel like an ending, but like a quiet clearing. After all the stretching and shrinking, after galaxies have dissolved into dust and the universe has expanded into an almost unbearable vastness, something unexpected happens. The story turns inward. Not away from science, not away from scale, but toward meaning. Because once you truly accept how small galaxies are, how astonishingly tiny all structure is compared to the universe itself, you are left with a question that is no longer about distance or size, but about significance. You see, smallness is often treated as a kind of failure. In everyday life, to be small is to be overlooked, diminished, dismissed. We equate scale with importance, volume with value. And at first glance, the universe seems to agree. It devotes nearly all of its space to emptiness. It scatters matter so thinly that entire galaxies vanish when viewed from the right distance. It seems to whisper, again and again, that nothing truly matters. But that interpretation, like so many others, is another illusion. Because when you look more carefully, when you sit with the facts rather than react to them, a different picture emerges. The universe does not reserve its richness for its largest structures. It concentrates it in its smallest ones. Think about what a galaxy really is. Not its diameter, not its mass, but its history. A galaxy is a record of billions of years of physical evolution. It is a place where matter has learned to organize itself in increasingly complex ways. Gas collapses, stars ignite, heavy elements are forged in stellar cores and scattered by explosions. New generations of stars inherit those elements. Planets form, chemistry unfolds, time accumulates. All of that happens inside something that, on a cosmic map, would be smaller than a speck of dust. And that is not an accident. It is not a coincidence. Complexity requires density. It requires proximity. It requires matter to be close enough to interact, to exchange energy, to build structure. The universe could not place that complexity everywhere without losing it entirely. If matter were spread evenly across all space, nothing interesting would ever happen. There would be no stars, no galaxies, no life. The universe would be smooth, uniform, and silent. Smallness, then, is not a weakness. It is a necessity. The fact that galaxies are tiny compared to the universe is precisely what allows them to exist as galaxies at all. They are pockets where the universe briefly resists its own tendency toward dilution. They are regions where gravity wins locally, even as expansion dominates globally. They are exceptions carved out of a rule that overwhelmingly favors emptiness. And those exceptions matter. Within a galaxy, the universe becomes busy. Processes overlap. Feedback loops emerge. Cause and effect intertwine across time. Information accumulates. A galaxy remembers its past in the distribution of its stars, in the motion of its gas, in the chemical fingerprints embedded in planetary systems. It is not just a collection of objects. It is a story written in matter. And the smaller the region, the richer the story can become. A star is smaller than a galaxy, yet it hosts fusion, magnetism, cycles of birth and death. A planet is smaller still, yet it can host oceans, atmospheres, geology, weather. And on at least one such planet, consciousness emerges. Thought arises. The universe begins to reflect on itself. This is the quiet reversal at the heart of cosmic scale. The largest things are simple. The smallest things are complex. A cosmic void spanning hundreds of millions of light years is vast, yes, but it is also boring in a fundamental sense. Very little happens there. There is no chemistry, no evolution, no memory. It is an enormous region defined by absence, by what did not occur. A galaxy, by contrast, is small enough for things to happen. It is dense enough for interaction. It is constrained enough for structure to persist. Its very smallness is what gives it depth. And this reframes the entire conversation about scale. When we say galaxies are small, we are not diminishing them. We are locating them correctly within the architecture of the universe. We are recognizing that the universe does not measure importance by size, but by possibility. It is tempting, when confronted with the vastness of the universe, to feel insignificant. To imagine that our lives, our thoughts, our struggles are meaningless against such an enormous backdrop. But that conclusion misunderstands what the universe is telling us. Meaning does not scale with volume. It scales with complexity. Your thoughts do not need to fill the universe to matter. They arise in a brain smaller than a loaf of bread. That brain exists on a planet that would not register on a cosmic map. That planet orbits a star that is smaller than a microbe in a scaled-down universe. That star resides in a galaxy that is dust. And yet, through that chain of smallness, the universe has produced something capable of understanding its own scale. That is not insignificance. That is extraordinary. The universe, in a sense, hides its most interesting features in its smallest corners. It spends its resources on emptiness, and then invests its meaning in rarity. Galaxies are rare. Stars are rarer still. Habitable planets rarer again. Conscious observers perhaps rarer than anything else we know. And yet, rarity does not imply unimportance. It implies preciousness. This is why the phrase small but significant is not a consolation. It is a description. A galaxy may occupy almost none of the universe by volume, but it occupies an outsized role in cosmic history. It is where matter learns new tricks, where time leaves fingerprints, where the universe experiments with complexity. And this is true at every level. An atom is mostly empty space, yet its structure allows chemistry. A molecule is small, yet it encodes information. A cell is microscopic, yet it sustains life. A brain is finite, yet it holds memories, emotions, ideas. The universe repeats this pattern relentlessly. Vast emptiness punctuated by pockets of astonishing richness. Once you see this, the fear of smallness begins to dissolve. Smallness is not a verdict, it is a condition, a requirement for meaning to emerge at all. And perhaps that is the deepest lesson hidden inside all these measurements and comparisons. The universe does not need to be full to be profound. It needs contrast. It needs silence so that sound can matter. It needs darkness so that light can speak. Galaxies are small because the universe is large, but they are significant because they are where the universe slows down enough for things to happen, where time can accumulate, where stories can unfold, and we are part of that story. We live in one of those tiny nodes, one of those delicate concentrations of matter adrift in an ocean of space. Our galaxy is not special because it is large. It is special because it exists at all, because it has endured long enough for stars to rise and fall, for elements to be forged, for planets to form, for life to ask questions. When you look at the universe through this lens, awe does not come from immensity alone. It comes from balance, from the way vastness and smallness coexist, from the way emptiness dominates, yet does not erase meaning. The universe is not trying to overwhelm us. It is inviting us to notice where significance actually lies. And perhaps that is why, after all the numbers and scales and shrinking and stretching, what remains is not despair, but a quiet kind of reverence. A recognition that we inhabit a node that matters, not because it is central or large, but because it is complex, fragile, and rare. Galaxies are not large. The universe is large. Galaxies are small in a way that allows them to be extraordinary. And once the thought settles, once it stops feeling abstract and begins to feel true, the story does not really end. It softens. It opens outward again. Because every time we understand the universe a little better, new questions appear. About what lies beyond the observable horizon. About the nature of space and time themselves. About the deeper rules that allow such a vast emptiness to give rise, again and again, to pockets of meaning. And so, rather than closing the book, the universe leaves us here, standing on a tiny speck of matter inside a small galaxy, inside an unimaginably large cosmos, not diminished by that perspective, but enriched by it, ready, perhaps, to listen more carefully the next time the universe whispers something about scale, about significance, and about the quiet beauty of being small in a place this vast.